Good morning, friends. This is your Suraj Singh speaking from Bharat, India. On this day, this is May 27, 2021. I could not connect to Facebook. I came back to YouTube just to talk because on this website I am unable to share documents with you. I can't share points, which was main function of my talk, because sharing screen means I can help you what I want to say. Well, no problem. Talking is also good sometimes. Usually, I want to share my views with you regarding engineering, regarding general life, regarding quality, and regarding COVID. All issues miscellaneously I share with you. And in this talk, I have seen, I can say, about field engineering, which involves civil, electrical, mechanical, and many other branches of engineering. But major portion is civil engineering, construction engineering, design engineering. And COVID is also a talk in that. COVID, though it's not related directly, but in safety issues, when safety is concerned, health is concerned, environment is concerned, or you can say some impact on designs of structure is concerned due to latest development, we can say that we have some inclination towards COVID also to draw help for ourselves. We have to think about our crew, our workers who are exposed in open to all kinds of hazards. And COVID-19 itself is a hazard, we know now. It's hazard, though it's not known hazard, but it's hazard that is invisible, and it has been impacting 8 billion people throughout world. And we are 1.3 billion in our country, India, Bharat, and now it has been working very efficiently in our country, and it's a cause of concern, it's a question of concern. We have to find solutions to that. We have been able to find solution till now. We have been failure till now, but failure or not failure, that's another point of view, but it is impacting us, and it's very serious situation. I'm not basing myself on what data are coming. That's not important for me. Important for me facts which are being observed, which are being experienced, and which are being seen. Very, very drastic situation in our country, and no one is responsible. In fact, nobody is very serious. It's all game. But as human being, a citizen of this country, it's duty of everybody to find, to know how it's happening and what's way out. So my concern about this is that because my field says, in my field, human resource is very important. First number importance goes to human resource, then it goes to material, and then it goes to equipment. Combination of all this human resource plus equipment plus material and supports, all can say some of this, and then determination and dedication go to go to work in combination. If work is to be done, all these articles, items, I said, this combination must work together. Otherwise, no achievement can be done. That's also a fact of life. And on top of this, all these must work qualitatively and quantitatively. Quanti Quantitatively working is not enough. It's like quality is like soul in body. If soul is not good, it's not attractive, it's not determined, it's not forcive. It forces human being to work. If soul if soul doesn't force, maybe I sleep. I sleep during talk itself because of something else. Now, engineering is something which produces. Engineering is something that gives physical work, that shows physicality. If you do engineering, it is shape that engineering gives to your imagination, to your design, and design is done by mind of designers, and those who are educated, those are qualified, they can do design, and also those who are not qualified, they can think and design. Design is done in every field, in every work, but in engineering construction and construction engineering is based totally on designs. And if designs are not available, what we have to construct, then we have to conceive that during construction itself, which is not right way. Last time also I stressed that COVID-19, which is which means you can say reduces immunity of people, and those who are already reduced, it impacts them. How we have to keep permanent enhancement on existing weak immunity for our workers? That is one question, which we say health, safety, and environment issue. Health, safety, and environment is permanent subject for field, for workers, for others who stay in open sun, open sky, and who work. They have to be strong. Our workers, our staff, they must be weather resistant, they must be hunger resistant, means they have to keep themselves fit for work all time. Now it is a question that those people who work in groups of many, sometimes 25 persons working together at one location, sometimes whole slab goes on and many people stand in groups. Likewise, particularly outdoor activities of concreting or shuttering or steel fixing or whatever you can say, people come together and work. And if they keep themselves distant, this is a problem. They cannot work to that efficiency which must be worked with. How to then chart out, redesign of this grouping? If you have to construct, this must be thought of. We have not only to deliver quantity, we have to deliver quality also. Rather, I should say, we have to deliver quality based quantity, qualified quantity, you may say, qualified quantity. Whatever product we deliver or we produce should be based on contents of quality, percentage of quality. And quality is defined on every project because quality is not unlimited, though it is unlimited, but we have to extract what is our requirement. That is very important point. Our requirement is based on our scope, based on use of that material, how long we want to use that, what is our budget, what is our cost. All these factors are kept at least while you can say designing scope of quality to be filled in, to be induced into that product. Construction world is different. Construction world and designs are linked together. And those who do not get this, they have to understand this. It's not that only construction. If you go to manufacturing of machines, if you go to manufacturing of something else, you'll find same thing there. But only difference is machines are manufactured in factories, in industries, equipment are manufactured in industries. They are undercover, they are better safe than those who work in open skies. There is reputation of work in that factory, whatever factory, manufacturing unit. So it's little different than construction engineering, field engineering of civil, because start of civil works, there is no cover when you start this. Even if you construct a toilet or a small guardhouse, you have to work in open. You have to construct a boundary wall, you have to be in open. In rain, in sun, in moon, you have to face all good or bad weather. That point we have to understand in the beginning itself. No protection from sun, from rain. Yes, work can cease for some time if there's heavy rain, but in ordinary drizzle or ordinary rain, work never stops. Same applies to formwork fixing, steel fixing, and other original items that start with when we open a project. These activities go on for months. For example, suppose some project has to finish in 1 year, maybe 6 to 7 to 8 months are consumed by structure. Means our people, or I should say people rather, people in construction are prone to adversities of nature, but sometimes it is good and sometimes it is bad, because when you work in sun you get a benefit of vitamin D you get, which makes your bones stronger. That's also a point. You'll find all those workers who are civil, who work in construction sites, they are better, they are more stronger than those people who work in air conditioned room or who are affluent in class. They have money and they don't bother about this. For them, these workers are considered laborer, means very low profile people. But they do not know that without these people's contribution, you cannot stay in a house where you are living in, and you cannot do anything in life. You cannot drive your car on road, because road is also constructed by such people. You cannot fly because of them. Very start life, very start of life. I mean to say, if you want to have good life, you must have a good house, good accommodation, and good infrastructural facilities that this will provide. Their blood, their hard work, their sweat results into buildings, into structures, and we should be thankful to them. But we are never thankful to them. We consider them as our servants, our dependents. Well, that is economical part, political part. I'm not going to that. I'm inclined to discuss about issues related to engineering and quality. If somebody asks you what is civil engineering, I'm just trying to deliberate on views. Means, after all, why it's called civil engineering? Why not something else? Just like machines, we call mechanical engineering because these are related to machines or equipment, and we call electrical engineering because it is related to electrical world. All electrical related issues are involved in electrical engineering, and machines issues are involved in mechanical engineering. Machines of all sizes, all loads. If you consider other engineering like agricultural engineering, agriculture is involved. And if you say electronics engineering, electrons flow is involved. I mean to say, civil has no structure which you call civil. In civil engineering, which we say, some some are specialized. This I'm a structural engineer. Some are I'm an engineer. I am road engineer. I am bridge engineer. People call like that. Okay, that's fine. They may be whatever sort of engineer. But point lines fact. Why is civil? Why not the other name? This name comes, it has come since beginning. I don't know which beginning, but civil is related to public also. Civil is related to public. Civilian, we say, not army man, not personal of some others. Is a civilian. This means it's got relation to people. Civil engineering has got relation to people, but other engineering have got relation to people as well. You can't deny this fact. If I say I am related to people as a civil engineer, then what about mechanical engineer? Mechanical engineer also is related to people. Electrical engineer is also related to people. Electronics engineer as well. Everybody is related to people, right? But why civil only? Think of. I'm just talking very elementary, it's very fundamental. Some people used to joke like this, oh, we are civilized engineer. No, it's not that. That's just joke. And they are mechanized engineer. Engineer is engineer. Only difference is civil may be given. I don't know why it is given, but when you start something, whatever, all over world, whatever you start, you have to start from soil. You have to start from dirt. You have to start from forest. I want to convert some forest or wood into city, let us say. This means this is forest, this is wood, there are trees, there are plants, there are grass, bushes, and maybe pool of leaves, plastics everywhere. Or you can you have to start converting that that location site from jungle, from wood to developed city. That is the job of civil planning of towns. When I say civil, it includes architecture as well. Just keep in mind, because civil and architecture are complementary to each other. They are overlapping fields. Though architecture is a little different in designs of spaces, but we consider together because both can't go without each other. So when we start something, we have to go to that place where there is no room, there is no desk, there is no electricity, there is maybe no water, but we have to do survey. Without survey, we can't do anything. This means that part must be considered, that we have to start from dream. When I want to see this area after 2 years to be converted to a township or city or a residential complex or something else. Your connection is unstable. Please wait while we are trying to reconnect. Why is unstable? I don't know. What's the reason? Well, okay, let me continue. So when I'm saying that I dream that I have to construct this jungle into city, whatever type of city, residential city, township, or some complex you can say, industrial complex, and we want to use sea. There's some reservoir below, or there is some gas below, like it happens, and we have to convert that area into refinery or into plants or into this area. Means it is directly related to whole use of that area into some object. Object is development, residence, residential city, commercial city. Means that project which you are conceiving and you are thinking, that will lead to that comprehensive use of development. If you say I change this area to town, it is complete object. We have to do something where there is nothing, and we have to change to some physical involved thinking. Means I have to think when it was old time, when I was young, to do table surveying, plane surveying, we had to do compass surveying. In those days, I'm talking of 70s and 80s, means it was too slow, of course, but elementary, very elementary. We did not have electronic instruments, but fundamental is same. There's no change. Yes, we are move fast. Of course, we move fast, but fast doesn't give something specific. Yes, it will save your time, or it may give more problems as well. But original thing is that I have no place to sit, but I have to do something. I have no car, or sometime I have car. I have to sit in car and make it my office, or I have to find some stone or here and there and sit on that to think what to do, take measurement or take some location or take some photographs or to think of what to do, survey work and all that. This means we have to produce some platform in beginning. In beginning, in initiation, a platform is to be constructed. Platform means not a timber platform of that stays. Platform means we have to create some engineering basis on which others would come. At least that base is required. If HVAC or mechanical engineer has to come to that area, that engineer will never come until some base is ready. That electrical person would never come, or those agents in market for marketing will never come, and all those who have to use that would never come until I produce something for them. You can say I am a guard there. Civil engineer is a guard, civil engineer is a watchman, civil engineer you can say is a sweeper, or you can say civil engineer is a cleaner. Means we have to clean that area first. Of course, I'm not going to, or someone is not going to clean personally. We have to take some machine with us or some people with us. We say we have cleaning. We have to clean this because at least we can sit. And we have to mobilize first. Mobilization means we have to, according to our program, we have to start that site and we have to go and start doing something so that we can sit there, we can base there. That is what this means. A comprehensive work, comprehensive field in profession of engineering, or you may say whole professions, a comprehensive work which is to be done is done by, you can say, undressed civil engineer. When I say undressed means we have no dressing sense. Who will look at us? And what's purpose of that? If I am well suited, booted, and well dressed with coat and ties and all that, and go in a jungle, what is meaning of that? Is temperature a requirement? Maybe it's too hot, or there is 140 kilometer of wind breeze, 70 kilometer wind breeze, or there is humidity or no humidity. I can't say what would imply on me as civil engineer, but it's my duty. I have to go. Maybe I have to stay there for a couple of weeks. Maybe I have to go outside for my daily use. There's no toilet. It happens. It happens in deserts. No toilet. You have to go to an open. It's different kind of initiation. I'm not saying this is for every project. Even if you plan it, you go for feasibility report, you go for construction. Yes, only difference is designs. Design previously was also done like this. When there was no computer, in those days, designs were done better done than today. Today, show is more than real designs. Computers have converted our engineering health into some kind of philosophy that you are pulled by computer in a way that you have broken your brain. A confidence generation has gone. We have lost confidence. Why I am saying that? When computer software is used, brain follows software. It doesn't follow calculation. It doesn't follow thinking. If you see people today who are computer oriented, I am also computer oriented, but I was non-computer oriented also. You can say up to 1998, I did not touch computer. I just touched first time in 98. And when I was, I think I'm 55 born. So you can say, what was my age? I did not like computer because first of all, it showed my eyes and then brain power. When you calculate something mechanically or physically on your tips or by calculations, you will use your brain much more faster than when you use tool like computer. I call it tool and it is tool. Your tool has made you tool now. You get my point. This tool, which is known as computer, it should be considered a tool. But what has happened in this transition from manual work to computer work? User has become tool. User. User has forgotten calculation, how to calculate. User has forgotten how to write. User has forgotten how to speak correctly. You can say user has forgotten how to read and what to read. No interest in reading, no interest in writing. If it is writing on computer, you can say style of writing, shorthand writing like that. Even if you write a for you, FOR, YOU is for you, the for and you. Means that writing skill has gone. I see on many boards of shops, spellings are wrong. Yes, that's what I'm saying. In connectivity world, we have been disconnected. In connectivity world, we have been disconnected and we have become imaginary lot. I'm talking about civilian, don't worry, that's computer. We have become connectivity less. We think just chatting is enough. Facebook connection is enough, Twitter is enough, but we forget this is not real world. Communication, this is not communication. If you have to communicate with people, interaction is a must. Interaction of every activity in life. You cannot understand anything until you are involved in that and until you are immersed in that. Immersion of your mind is very important, like swimming and like, prayer, doing prayer. Thinking means prayer, thinking means concentration, and that is what design requires. I'm just trying to tell civil engineering designs are very crucial. Don't think what you look at slab or house construction, that is not real one. When you see some houses being constructed, some building is being constructed, some flyover being constructed, some road is being constructed, some canal is being constructed, some dam is being constructed, airport is being constructed, that is only fake imagination. Real imagination is in design. That is being given shape only on site. Shape is given, product face is given, of course with complications. I'm not saying that's fake in that sense. It's fake in a sense you think they are doing everything. No, there is multifold work done behind. Multifold work. A common person cannot even imagine. Even if you construct small house, as I said, guard house or small house, a boundary wall, you think it has come automatically. No, it doesn't come automatically. There is a basis behind. Lot of work is done behind. Even if you use computer, we have to do a lot of work. Computer cannot do anything on its own, and if you think it can, this is not correct. Yes, it can be used, again I say. It can be used very well if you know its use. It can be very well used, and people are using it. For example, they are using it for typing, they are using it for calculations. Lotus 123 was very good spreadsheet before for purpose of calculations, which had been named now Microsoft Excel spreadsheet. It's a powerful base if you want to use it. But people don't use it properly as well. Only those who have studied they use. It can be used number of times very fast. If you take interest in understanding that, don't go to formulas alone, which was what formula they give. They give because they devise those formulas, you devise your own. I'm just trying to say, if you even if you want to use computer, you have to understand computer. You have to understand software. You have to understand what is what, how it works. Just like you say types on MS Word. This means every key is connected to some language. You can say digital, we call it digital 0 and 1 bytes. Every key is connected to certain numbers. And it works. It's machine language. I'm not talking of software language, HTML. I'm talking machine language, which is behind that. Same way, Excel sheet, for example, each cell, there are millions of cells in Excel sheet, unlimited. Each cell is connected to what? Each cell is connected to calculators. So there is no physical calculator, maybe it is flash calculator. Each and every cell is connected to calculator. This means while you work on Excel sheet or Lotus 123 sheet, you deal with millions of calculator together. Your key, you know, your cursor, wherever it goes into calculator. But you don't work on that. You just rarely use auto sum, for example, you use. Yes, auto sum. There's a formula for sum. No need of using auto sum. There's a formula for you can say subtraction. You no need of using. There's no subtract as well in that, but there is a formula for multiplication. There's a formula for division. There's a formula for square, under root, cube root, all that. If you want to, if maybe you're weak in mathematics, but you want to use mathematics, so you use Excel sheet properly. Don't think of what is given in template. Don't depend upon template. You'll find that. That's a part of, you can say, intellectual engineering. And in our field engineering as well as in our designs, we use it very promptly. When I say, if you understand that, you can use it for purpose of designs, for purpose of computation, for purpose of quantification, for purpose of redoing and redoing and redoing and trials. Only benefit we get through computer is number of trials, number of operational calculation research, I can say, rather than research. In past, difference was that we had to calculate. Suppose I did one calculation in 1970s, 80s. It took 10 pages calculation to find quantities. Maybe it took to me means taking off from drawings takes same time. If you compare to that time in 80, 75, 80, or to now, taking out dimensions from drawing is same. It doesn't make a difference if you do rightly. Taking off, we call it taking off dimensions from design drawings and keeping or writing on paper or entering in your cell on Excel or you manually. It takes same time. Only difference is calculations. Example, I write length is this, width is this, and depth is this. I have three numbers, three units, length into breadth or into thickness. I have to find volume of that. Now I can say I directly use one formula and work on this. And maybe there are 5,000 calculations I have to do. I can immediately do calculations, but entries I have to make. Yes, only do I not to write, I have to use cursor and key in. In those days, we had to write. And then we had to use manually all those 5,000. That took time because in those days, even calculators were not available. And we had to calculate manually or using slide rule. Difference is like that. Speed was less. Speed of using computer has gone manifold and manual takes time. And another benefit is if we had to that time change one, then we had to recalculate, redo. But now because we can change anything anytime, and that has created carelessness because we have to take ourselves to different dimensions. Okay, I try this and I try that on same sheet. Okay, I take this, I change it, and now try that. What happens that I don't remember what actually I did. That's what I'm saying. There is merit of using software and hardware, and there's demerit also. Demerit is that I cannot assess what result this computer gives is right, or maybe I have caused some error. I can't even identify my errors. That's also true because my eyes are so covered in waves of computer, in radiations of computer. I am many times not able to locate my error. That is very important point. And that's why I say this is a device, this is a support, that support in field. Nowadays we have sometimes for calculation purpose, but in those days we had to use mind only. So that initial stage of site, whether to survey or to do some work, was very crucial. Now people say, I don't want to go to site. I can sit here in office and go to Google Earth and see what is that. Yes, that can happen. You use Google Earth, open that program, live program, and see that is site. This is my site. I take measurement of this from here. That can work for purpose of estimation sometime. I did this. If I say I'm sitting in this country, suppose I'm sitting in one country, and there's another country which is 1,000 kilometers from here, I open that location in that country and try to find out, and maybe I get some use of that. It's not always necessary that you have to go daily to that area and see, but you have to go and see. That's also true. So when I say civil engineering, meaning civil engineering is you can say everywhere it can step in, everywhere. It may be civil work, or it may be army work, it may be whatever else. Civil engineer is required everywhere. There is no place in life, there is no, you can say, place in isolation where civil engineer is not required. You can consider sewer line, water line. You can consider whatever flood. Means there is no place you can say you have to go without civil engineer. That's why name is given, because it solves civil problems of a nation. Civil problems, military work is also civil problem because ultimately they do for civil. I think that's the only reason that this name civil is given, because we deal with civil issues, national issues rather we should say. All issues we deal with, and it is therefore beauty of civil engineering. Beauty means not beauty of attraction, but beauty of determination. I don't care for my color of face in sun, it is hard, it is shining or it's not shining. And it is only reason that everybody could not enter this field. If you enter this field, you can't expect that a chair is available where you go. You can't expect a desk is available where to go. You may have to stand for hours together. You have to sit in sun, or you have to means it's kind of a type of self war, self defeat or self victory. If you can't do that, I think it's no use to be a civil engineer. Civil engineer means you have to be away from comforts. That is the real meaning of civil engineering. What is happening today? Those who have high education, higher degrees in engineering, and they think we are specialists, they try to work in designs all the time. This is general tendency, and they think we are superior. But I don't think that way. Superior are those who deliver product, who deliver projects. Because without delivery, there is no meaning of project. If I am a designer, I design excellent, excellently. I design excellently. But a person who does in field physical work, or you can say transformation of that design into physical entity, if that person does not follow all specifications, all designs, everything as are required, you can say that product, whatever it be, that structure won't be as was intended in design. That is main difference. Means site person we call site, rather than factory, or we don't call it factory, we don't call it industry. Though it is industry, but we don't name industry, we call it site. Site generally mean where work is done, though everything is site otherwise. We say this building is situated there, this factory is situated, we say that. But site means where work is done and delivered itself there. Where we do work and it is permanently done there, it is delivered there itself on papers. That is called site. Construction is generally done on site. Site handling, though it is considered secondary, it is only in relative terms, comparative terms. But you think that, don't forget, that work is forever. Whatever one does one day, next day it is forever. Because same day you may remove it again if it is wrong and do somewhere else. But once it is done, it is done. If you want to change it, you have to remove this. You can say dismantle that. In organizations, in factories, continuous process goes on, continuous. There are defective parts as well. They say, oh, how many percent parts are defective? They check sometime. Just like Sigma says that there should be no more than 3 defects in so many million. That is their consideration, their norm. But in our norms, in civil, there's no such norm. Everything should be perfect, should be compliant to requirement. If we cannot do that, If we cannot comply with that, that is not acceptable. That is called substandard. So we can say this person has done substandard work. It's not according to mark. I don't know, every time your connection is unstable. Please wait while we are reconnecting. Why it's coming though it's working well. I don't know what's the reason behind this. Why they are saying, it's no sessions are coming. Your connection is unstable. Please wait while we are. It's coming every other second. What is reason? I can't understand reason behind this. I don't know. Facebook did not start video, and this is giving also that. What's this? Anyway, just now. Well, gentlemen, I was inclined to define something today that is civil engineering, and I'm just defining it because people must know facts. Civil engineering is little different. If you think intellectually, I would say it is most difficult engineering intellectually. Theoretically, you may say. Theoretically, most difficult engineering is civil. Theoretically, which involves designs, which involves complete subjects. You may say, why I'm saying this? You may ask this question. Why other engineerings are not so difficult? Other engineerings are not difficult because in other engineering, imagination level is not that high. You got my point. A specific point in this engineering is that we imagine every structure. Imagination is much higher in initial stages. We imagine, imagine there is a deflection. Deflection, I mean to say, there is, say, there's a column, which you get pillar, there's a beam, and this go out of their position. Slab, this goes out of position. Imagine like that. Imagine how much load is coming on that. We don't weigh, we have no balance there to weigh. Where there's no way bridge, but we consider this is load on this. And that's real one, calculated one. We imagine how much load is coming on this and what is result of that load, and whether am I able to provide a structure to resist that load successfully in all considerations, that it should be safe, this should not break, this should not fall. All these considerations, if there is impression of wind on this structure, there's impression of fire on this structure, there's impression of seepage on this structure, how to handle that one. That is real wonder, which people may not understand. Every point is considered behind scenes, and scene is site where work is done, but before that everything is done. We decide how much I allow this building to tilt, for example, how to allow this building to move, and how can I work on this to bring it back. You got my point. Say this structure has moved some say 10 centimeter, 5 centimeter from its original place. Why still remaining on foundation? One part has moved, say top part has moved. It should come back, right? It should come back if it's moved. Shall it come back or it shall not come back? That is my question, and I have to answer. Yes, I have provided this strength enough in first issue, in first consideration, that when it moves at one point, it should not fail, it should not break, it should not down. But in other way, I say it should try to come back. It should try to come back to that 5 centimeter so that it is safe again in original position. Or how much it can come back, Say it comes back only 48 mm. When I say 5 centimeter, 50 mm, so it comes back to 45 mm, and 5 mm it doesn't come back. That is change of structure. The stress on structure, you say that this has reformed. Original form has gone, and movement of 5 mm has become permanent. You can say from there on, structure starts getting deteriorated, it starts getting distressed, reformed, deformed. That is what we think. And how to stop this? Say this is a beam, it's going to fall from this. How I have to stop that? That is what we consider. It's not going to fall, but we imagine it will fall or it will bend. We say it would bend by this load. That bend is not real. That bend would not work, because if we construct in such a way that it bends and comes down, then there is no meaning of design. Design says you think of conduct, you think of behavior, you think of tendency of this member of structure, it would work or it would damage. You evaluate that by your theorism, by your theory, by your contemplation, and how to make it stronger or resisting, so that this bad activity does not work on that. That point we consider. So, okay, it's time now. All right, let me get 10 minutes more. I go for 5 minutes then. So this is what is very important point. What happens? There are so many theorems, there are so many formulas, there are so many calculations. I say a lot of calculations. You can't imagine. If you are not civil engineer, even if you are mechanical engineer or electrical engineer, you may not contemplate that. Applied mechanics, strength of material, theory of structure, designs of structures, fluid mechanics, pre-stress concrete, RCC, structural steel, previously timber designs, stone masonry, brick masonry. So much was covered in civil engineering, surveying, construction, geology. You may be surprised to know, to become educated civil engineer, how much was required to be learned. It was necessary, and without that, we could not do anything. All that stays in mind. It doesn't mean that doesn't stay in mind, but we can't use it because we forget it. Everybody forgets. It is natural until you re-practice it or review it. In your work, in field, whatever is required, we do. This was part of design. There's another part which is part of how much material we have to use for this work. Quantity of material, that is very, very important. We should know, for example, in this building, how many bricks we are going to use, how many blocks we are going to use, how much sand we are going to use, how many bags of cement or lime we are going to use, whatever, even how much water we are going to use, how many nails we are going to use, how much excavation we are going to do, how much excavated material we are going to fill back, or we have to import it from some other area. All this is done. Maybe people do not know that. Each material, each element is worked out in quantification. Element quantification, minor quantities. Every item is worked out. We know quantity of every item, and then we find out the rate of that item, how much it will cost to this item. We can say this is analysis of costing, analysis of rates of each item, cost of material, cost of worker, cost of machine, cost of supplement item, and cost of time. Whatever we think we have to spend on that, each has to be calculated. So we can say we got unit rate of this item. If it is millimeter item or meter item or square meter item or cubic meter item related to unit, this shall be our expense on this item, which is called quantity surveying or estimation and costing, without which we cannot say budget on this, budget requirement on this project. I'm telling you in very, very elementary language, very, very clear language. Means design state was one. This is now estimation or quantification stage. Then there is construction. These are three major brain using points. Then there are supplementary brain using point. We have to do planning. We have to consider contracting, and so many like that. But if these three are not available, then nothing can be done. Each work is to be defined, each activity is to be defined, it has to be elaborately defined. So you think of volume of work that's required. Easy to say, oh, I'm doing, see, this column is done, this pillar is done, this lantern is over, slab is over. That is physical, that is not logical, but that is final one. That is based on all these acts I'm explaining to you, and that is main part. So you can see workload of workload of buildings, workload of structure, as far as you know text is concerned, as far as study is concerned. This means what we studied in our engineering time, education time, same we study here. Rather, it is practical. It's self-decision making. No professor is there, no lecturer is there. There they guide. Here, demand guides us. Demands guides. So say there is a designer who designs something, and there's a person who has to do that. Designer guides that person. You do like this, and that person has to do that. But there can be counter complaint. Okay, your design gives me this problem. You solve it first. Otherwise, it's not easy to do it. In that case, site guides that. But that is interactivity. I'm not saying there's a refute or there is dispute or something. Each guides others. That's we call it coordination. And because my talk is confined to quality, you can see layers of quality then. How many layers of quality work together? A person who designs, there must be quality accordingly. There must be quality accordingly in design. Otherwise, design would be defective, and we are not there to work defective. They are not there for object of defect. We are there for solving problems. Civil engineering says you have to solve problem. Though it is engineering says, every engineering says, but civil engineering in particular solves problems. Problems like we have to start from soil itself. I am going to produce something here on this soil. But what this soil says, what does this soil tell me? I have to raise questions. Is this soil good for me, or this is not good for me? Not for me, I mean to say, for when I am saying me or I, it means project. I am speaking on behalf of project, not for me. So what that project requires, and that project required will require according to loads on that project, forces on that project, total weight, bending weight, deflecting weight, all weights what we say, conclude, sun impact, thermal impact, air impact, water impact, humidity impact. This structure would be subject to all those impacts. And then, as far as structure above ground is concerned, fine, we have gone to that. But ultimately, structure is not going to stay in air. It has to sit on soil. And there is no further end. If soil doesn't accept this, it just won't work. If soil, or you can say part of earth, on which this structure is going to sit forever, if that soil does not permit what I said, can structure be done? Can structure be sited? It cannot be sited. That portion on which it is going to sit must have better strength than what we require. Higher strength when I say all properties. So we have to talk to soil first. How do you do soil? My forces are coming onto you. My structure is going to come onto you. It shall sit on you for so many years. You have to respond to that. If soil can respond to that, then it responds to me and I respond to it. But say, no, I'm not that strong, my dear. I'm not here for you. Either you remove me and change me, and if you want to use me as I am, then sorry, I don't accept this structure. Will you believe it? Shall you believe what I'm saying? Soil answers that I'm not going to allow you to put this force on me. I, if you want to put this force on me, then you have to talk to my sisters below or my parent below me. Go further down and see what is their value, because where I am sitting, I am not qualified to help you. You have to find some other market area, and that market area lies below me. This means soil strata is not uniform. It varies from ground level down. If you go down and down, you will find different classes of soils, different classes of layers of soil, different percentages of water or moisture, and different sizes of stones or sand, or what means you can't say what's there. This means you have to talk to soil to know what it is. Is it my friendly or it's my against me? Can it help me or can help me? And we call that soil investigation. We investigate crimes. This is also investigated. We have to investigate earth. We have to investigate my area where building is to sit. So if it doesn't suit, even after thinking of treatments, even after thinking of what best it can provide, I either have to change my design according to site, I have to change my foundations according to its properties. Then it says, okay, if you do like this, I accept. That's what I'm saying. Every stage, every part of stage, every act in civil engineering, even sewer line, water line, septic tank, containment, all require designs. All require designs and then construction. So you cannot simply say, we have constructed it, or what I was saying, I have done it to do. I have done it has no meaning. If it doesn't sustain that, if design doesn't help sustain my building, how can I say it's okay? Will you give me 5 minutes? I'll just go to Paris and come back. Just excuse me for that. It's important one thought. Some crowds will be waiting for me. I'll be back within 5 minutes. Sorry for that. Okay, gentlemen, continuing. I was talking of soil. I consider soil as best material that we have to use because this is founding material without which even gold is useless, diamond is useless, uranium is useless if I can't use soil. Soil is considered nothing here by people. Oh, this is soil, leave it, throw it. Yes, you think, but for not forget, whole earth is soil. What is earth? Rock, rock that contains this soil. Without earth, you can't live. We are living on what? We are living on earth. Earth, which is called, what is earth? Have you ever thought of? If you read geology, you'll find meaning of earth. You say it is spherical globe, elliptical globe. You may say that. Yes, that's right. This is for whom? This is for those people who are occupied of earth. Though they are temporary, they are not permanent. It's lithosphere plus aerosphere, we call it earth. Lithosphere and aerosphere. Aerosphere means air part of earth, which is say, let us agree, let us say up to 20 kilometers or 20, a little more from sea level or earth level, surface level. If you go 20 kilometers around this, means imaginary sphere about this earth sphere, lithosphere I should say rather than earth, because earth is equal to lithosphere plus aerosphere. Lithosphere is solid part which contains water also, and air is air around this, encompassing this sphere. When we say earth, it includes air. Remember, when air portion is finished, then space starts to come in. And this means that earth is a part of solar system, and that's fact. And this also means that earth lies in space. You may not understand this. Earth is also having a space around it. This earth has this earth has too much wealth in this. All economy that we talk of today, we talk of we I have this economy, I have that economy. We have got so much oil in this, so much reservoirs in this, so much quantity of gold in this, so much quantity of diamond in this, so much quantity of coal in this. All boost. They boost as if they are owner of this. You know, these countries boost as if they own this. Yes, they own because they occupy that portion. But question is, do they own wealth of earth? On what basis they claim that we are owner of that? This earth is for everybody. I'm not going to that political discussion. But fact remains, earth has different structure in this. There's also structure. Geology says that first 35 kilometers, then another 3,000 kilometers, and then another something. And it is assumed that up to center of this sphere, this is about 6,000 something kilometers. And you can say total diameter is around 12,500 kilometers. Can you imagine volume of this? Volume of this, can you imagine? What is volume of this? I'm talking of quality requirement. And that's why I have to cover various facets of this. Because quality cannot be defined in isolation. You cannot say that. Quality, which has so many layers for its product, and that is structure, can never be defined in one isolation. It has to depend on each other consideration. And that's what I am inclined to express here. There are various layers, as I said, in Earth. We know very little about Earth. Scientists, engineers, and all those who are involved. We know very little you can say. Not even 1 over 1,000. not even means not even 0.1%. My my question is, if say I want to stay in a room, my assumption is I want to stay in a room that is located 1 kilometer below surface of Earth. I want a room there. Can someone construct for me? I want to stay in a room that is built 1 kilometer below surface of Earth. Can it be done? Size of that room may be 10 by 10 or whatever. Is it practically possible? That is my point. It's not possible. Currently, it's not possible. Maybe in future it is. I don't know. No one has capacity to do that. Can I go and sit on ocean floor? You get my point. There is ocean. I want to inspect. I want to tour its floor. We go and tour every day, right? People go and enjoy the site visit, that country I'm going. I'm going to that hill station. People go. Now I desire to walk around and to enjoy sea floor or ocean floor. Can I do that? I can't do that. No one can do that. So even submarine cannot reach there. Nothing can reach there. This means I have no controls on Earth. I have no controls on lithosphere. I have no controls on sea. What control do we have? Then we boost a lot. No one has any control on this except to use it. Even these reservoirs from where we get oil or this fossil fuel, this may be 2 kilometer, 4 kilometer maximum from surface. And they use sea for that purpose because it is easier. It's easy. Maybe it's not part of civil engineering, but it's very much part of civil engineering. Very much, if you think so. That's what I say. I want to construct a room. Can somebody help? Though I'm a civil engineer, I don't know how to do it. I can't excavate up to 1 kilometer. Can't excavate. Even if you want to excavate something for basements, say I want to construct 5 basements, 5-story basement. We may do it. But I say I want to go to 1 kilometer down. I want to sleep there. No way. That is where we have to think of what is value of our work, what's value of our quality. And that's what I say. We do not know anything about soil. Soil on which we put our building, we are not interested in that. We are interested in building. I am interested in my building. I'm not interested in soil. This means I am interested in my body and I'm not interested in my soul. But I forget that body plus soul is equal to living being. If I have only body, I can't live. And even if I have only soul without body, it doesn't matter. It doesn't make any difference. Both can't work. Body and soul combination only works. Otherwise, they can't work independently. This is a very important point. I'm not going to spiritual world, no. Electrical energy of my body is my soul. Electrical energy or electrostatic energy or natural energy, whatever you name it. It contains solar energy, it contains water energy, it contains heat energy, it contains air energy. All elements are included in my that soul electrical energy, soul air energy, whatever I have in my body, it is because of joint function of soul and body. This means nature says what you think can't do without my support. I can go to doctor and ask him, please, I'm sick, this is my problem, treat me. Doctor accepts and treat me. If doctor says you have no problem, you are fit, and I say, no, I'm feeling pain, I can't sit together. Say, no, no, there's no such nothing. There you are fit, you are just psychological problem. That's what doctor says. But because it's not field of doctor to think of other item, that power of nature of soul, and doctor is limited there. No, your body functions are okay, you are fit, no report says anything, you have just psychological problem, go and take rest. And even psychology doctor can't tell him because there's no problem. Problem is in soul. Same I say, you have to make your soul strong in that case. If my soul is weak, people come, oh, you are under depression. They won't say your soul is weak, or you are depressed. Yes, I am depressed, that's why I am weak. You may call it upgrade your soul or soil. I am comparing. My foundation is soil, my body's foundation is soul. If my body is weak because there is something wrong in my soul, I'm not able to get energy from soul, and I'm getting weaker because my control is soul. I have to control my soul, and soul has to control me. Both. Same way, soil has to control your structure, and structure has to depend on soil. If this equation is not allowed, either building will suffer or soil will suffer. In both cases, whose loss it is? Is loss of building. If soil says, I'm not accepting your load, I am sleeping, I'm going down, what shall building do? Nothing. What shall structure do? Nothing. If soil says, no, I am very strong, I fight with you, do whatever you want, I won't sit down. The building is happy, oh, I am sitting on a strong soil. That's what I say. Read soil, study soil, test soil before thinking of anything, because it's never stable. Soil is never stable, just like soul is never stable. Soil can change its property. It is impacted on by wind forces. It is impacted on by water mobility. Water, you know water mobility, what I mean? You say, why is talking water? Where is water in soil? Soil has also water. Soil is also moisture. In fact, sometimes water table is high, or it is near foundation, or maybe there is some river flowing besides. There may be beach or sea work, or you can say there is some other source of water below your building. You are done. So water can rise or fall depending on situation, depending on rain, band or something. So if suppose building exists and soil invites water from somewhere else, good quantity of water, and what type of soil, that's a question. It may be sand, it may be lime, it may be gravel, it may be clay. So many types of soils are there. Every soil has different nature to respond to water. Some soils are good with water, means they allow water to pass through it and then it's dried out. Maybe sometimes it impacts it, sometimes it doesn't impact it, depending on velocity of water flow below there. Or there's some soil which don't like water. They want to absorb it, but they don't accept it. Clay is one of such soils. Clay, clay, Clay. It's very small word. It's like sand is very small, SAND, but both are different. Sand and clay, both are different. You can understand that sand is beauty of desert, right? Sand is beauty of desert. Clay is not beauty of desert. Clay is beauty of fertilizing, beauty of farming, beauty of fields where crops are grown. Both have different properties. You will not find capacity of growing in desert, but you shall find capacity of that where clay is available. So clay is, you can say, crop soil generally. Property of clay and property of sand are reverse. Just like I said, sand can allow movement of water, flow of water, because its pores are not blocked, its voids are not blocked. But clay doesn't allow that. You know, clay, product of clay is your pitcher, surahi, ghada, your, this WC seat, you know that? It's clay, China clay, your wash basin. Like that, there are so many items which are born of, which are product of clay. It has very significant property in relation to sand. That does not contain, sand does not hold water in this. It drains out. But clay holds water in this. It doesn't allow its draining. This means it has a capacity to absorb water and keep within this. It accepts to swallow. It accepts to swallow change in volume, but it doesn't accept to allow that thief water, robber water, to go out. Means it's police. It captures water. Sand is not police. Sand is civility. Okay, go, no problem. I allow you. Now think of both. If your foundation soil is clay, what shall it do? It is very good for crops, I said. It's very good for fertilizer because water is contained in that, and that water can flow upwards in forms of very thin wells, very thin wells, like capillary, we say capillary. These are pillars. Capillary, we call it capillarity. Pillars of water, very thin pillars of water move upwards, hundreds and thousands like that. Not flow of water, I say caps of water, wells of water. Capillary, we call it capillary action. These flow up. And these thin layers, when vertical columns go upward, your tree, your crop can withdraw water from that. Because your crop or your tree doesn't want to drink like we drink in glass or tumbler. They want to just suck through trees, sip. There's a sap in tree. Through that sap, tree consumes water. Likewise, your crop does it, and likewise, all green products do it. So we have now to think of if that soil, clay, swells, means it changes volume. If it changes volume and my structure is resting on this, what shall happen to my structure? If clay doesn't care for structure, it cares for water. I want to hold this water, and I'm little fat, no problem. I'm swelling, no problem. This means this can harm structure. So that's what we have to investigate. Sometimes people don't understand this. What happens, say, there's no water in clay, suppose, very limited water. In that case, it looks very strong. It looks very strong. And sometimes there's too much water in that. Then it looks there is nothing in this. There's nothing in this. Got my point. But we don't want a soil which has nothing in this. We want a soil that is everything in this. This will clay I'm talking, it contains many minerals. Maybe you did not hear that. Those minerals actually act against this soil when they come in contact with water. And that is technically speaking, for example, Mont morillonite is one such mineral. Mont morillonite. M-O-N-T Mont, M-O-R-E more, illonite, I-L-L-O-N-I-T-E. Mont morillonite. That is very much water absorptive mineral. It changes its volume, it changes soil and everything. There are many more minerals which are not that much harmful as Mont mineralite is. So when we design a building or we think site building, we have to know what is class of this soil. Shall it accept what I am going to work on this and through structure, or it shall not accept. Then we have to think, but I have a compulsion that I have to make a building here only. My compulsion, who shall solve? There's no way I have to do it. If that is the case, then we have to think to install that type of foundation which can sit on this successfully, when which is not refuted by this soil. This soil accepts that, accepts as to maximum extent possible. This means I have to change my thought on foundation and have to design that level of foundation, which may be raft foundation, we call it mat foundation, or otherwise we have to forget this level of soil, let it remain there, and we want to go further down, and we want to find a strata on which good strength available, is available, and I can site maybe 10 meters down, maybe 15 meters down. And when we do that, means we leave foundation base as it is and connect it through piles to that level. So our load of building goes to those piles and it does not go to clay. And those piles on which I am going to rest, there must be such strata available. Such strata must be available there. It may be soft rock, it may be soft sandstone, it may be hard rock, or like that it should be. So I have to pull my foundation below through that pile. So it works. Or otherwise, I have I don't have such plan. Then I say, okay, soil, you are not good. What to do? But can I change you? You got my point. I say, okay, I have to put my building here. Can I change you? This soil is not going to say, don't change me. But this is my assumption. Okay, I change you. For example, there's a layer of 40 centimeter. I say, okay, I remove you. Your bad layer everywhere. I remove this and I put better material so that better material will be strong enough with sustainability to transfer my loads to further below layers. And that process of soil removal and insertion in or filling in good soil, good material, that is called soil improvement. You think of means what stages are there? That's a kind of surgery. I am removing all bad soil and filling in with good soil or good material, which I will compact properly and make it a good base for this building. It's called soil improvement. How many people know about this? They just know they are doing something on soil and that's it. That's what I say. Civil engineering is hidden one. Only civil engineers know. Public doesn't know, while it is public who should know. Because whatever service is provided by professionals is provided for public and not for their own. But there is a lack of understanding, there is a lack of continuity of education, and there is a lack of people are not educated properly about engineering. It is considered as, you know, nowadays considered as bothering subject. This doesn't give money. Engineering doesn't give money. This is what people think of. Well, my purpose is not of money or no money to tell you. My objective is that we should understand quality of work. What I told all, it's not design issue, it's not something issue, it's issue of project. That involves design, this involves implementation, this involves foundation, this involves everything. All items are involved this, and that is beauty of this engineering. This is done only in civil. Even mechanical world cannot design foundations. If they can design machines, heavy machines, they can design force hammer, they can design whole machines, and these machines, wherever required, it's load to transfer to surface, transfer to pit through foundation. That foundation is also given to them through civil engineering, where this machine has to fit in projects of refineries or plants or facilities. Those all are designed by engineering, by civil engineers. There are hundreds and hundreds of thousands of machine foundations existing all over the world, maybe in millions. Heavy machine, light machine, medium machine. Those foundations are available throughout world. Otherwise, these plants would not work. Your facilities would not work. These are working because because of that reason, a foundation is available. So it may be factory shed, it may be factory machines, it may be factory plants, or whatever it is. You will find one type or other type of foundation designed and constructed by civil engineers. This means they cannot stand without civil engineering. They require civil engineering for their engineering. They, for example, mechanical equipment requires electrical energy, and that electrical comes to electrical person. So only difference is dependent engineering and independent engineering. You may say that original engineering or supporting engineering. I'm not saying, I'm not boasting about that. I'm just trying to tell relations. If you say raw engineering, if something is raw means natural. You see example of solar system. I'm just referring to that. What is solar system? If somebody asks you, you will say there are 9 planets in that, and sun is at center of that, and all are rotating in their own orbits, and sun is rotating on its own orbits. This is what we understand. We also know that Earth or all these planets which we contemplate that these are parts of solar system, those keep on moving around sun in addition to their own axis. It is true or not? I have not to discuss on that, but I have to discuss that yes, this is happening. This has been happening, and this shall be happening forever. And if you calculate out, you'll find that these planets are very much dynamic 24/7. If you calculate about Earth, if you calculate, you will find that it is having very good speed on its own axis because we have diameter of Earth. Because of that diameter, we can calculate circumference of Earth, and we say that in 24 hours it revolves on its own axis. So if you divide by that circumference of Earth to 24, if we divide that circumference to 24 by 24, we shall get speed of Earth per hour. This is only for this purpose. It's not for research purpose. I'm just trying to tell you what Earth is. And also If because Earth moves around Sun, and it takes 1 year for it to complete one revolution. What size of Earth is and what size of Sun is, we know that. We know that. So we know that this orbit around Sun, like orbit around Sun, with what speed it would be, because in 1 year Sun completes, I mean Earth completes one round around Sun. And what is diameter of Sun? Let us say now. If you find that what is diameter of Sun, I will say speed of Sun, we'll say it is 1800 kilometer per hour on perpetual action. Approximately, I've calculated. I can't show you that one because of screen share is prohibited in this. And also, when you say orbital motion of Earth around Sun, this is about 1.25 lakhs, 1.25 lakhs kilometer per hour. Can you imagine it? Imagination of 1800 kilometer on perpetual action is also not digestible, but okay, we have to digest it because flight also work. So we can say we are on a flight all time, full hours, 24/7. We are on flight, though we don't experience that. Everybody is in flight mode on Earth. And I say orbiting Sun, you know, Sun orbit 365 days. Everybody knows it. And we know distance from Earth to Sun about 15 crore kilometers or 150 million kilometers. Because we have that radius, then we can find diameter also. And when we have diameter, we can say it's pi d, which is circumference. And when you know pi d, and we have 365 days and 24 hours per day, we can define that diameter, we can define that length, and divided by 24/7. So we get speed of whatever machine is very high, and this is 1.25 lakhs kilometer per hour, which we can't digest, but we have been digesting that. I'm just giving an example of civil work. You think of these planets, who built them? I did not build them, you did not build them, no civil engineer built them. Who built them? Civil engineer God. Civil engineer God. God civil engineer. Who is he? I don't know who is he. I don't want to go into that title given in holy books. I'm not related to that. But there is someone to whom we can call God. We name it God. And that God has given us everything. And that everything is very important. And this solar system is also a part of that God has given us. But how it was constructed is a question mark. Scientists may say anything, Big Bang Theory and that theory, I'll leave it at the side. I'm not interested in that. I just imagine if I want to construct a building, what I need. I need this and that and that and that and that. I list out. If say I have to construct something in solar system, not on ground, can we do that? Still we can't do that. Impossible. Current impossible. Where do we stand then? If I cannot do this, I can't answer this. God did it. These spherical buildings, you can say, for God, this earth is a building, sun is a building, Jupiter is a building. Is it? It is. what constructed is. And so much intelligence applied that none of them is stationary. None of them. These are having two types of motions. Internal power use, that is for, you can say, for just to ensure that your proposal has this much volume today and you to do it. What I want to say is, can we think to construct solar system? It's out of imagination. You can say it's a fake statement. Yes, it's fake. But I want to contemplate. Contemplation is not fake. Imagination is never fake. Got it? Contemplation requires brain power. And brain power requires heavy power. Just I refer to this. Nobody is going to construct solar system. It's just an example of standard of engineering. I only think from where this metal could be arranged. It's immense, immense material. I have worked out some quantities of solar system planets. When I have some chance, I will share with you. Here I can't share with you because document sharing is not permitted in this. I'll share in first Facebook sometimes. We have to know all that. That is very standard work. If you do not know all this, I know practically you will not get any benefit, but required is not practical. Required is of their professionalism. Now we go back to our original discussion on buildings and structures, and and motto is quality. How to achieve quality, how to improve performance, how to move our plans, and how to talk of whatever problems appear to disappear them. That is immense requirement which we have to analyze all days, every time, during designs or during physical work. It is continuous process. It's not 1 minute or 2 minute process. I cannot say I've done it. It's never completed. If it's completed in designs, it's not completed in construction. And if it is completed in construction, then defects are exposed during maintenance of that. Maintenance also is very important. So when I consider quality in bracket, it has many meanings. It has many meanings, and if these are not done, means bracketed quality, which is a must. If it's not done must, then it will give you problems. Certainly. When I say quality, its first criteria in construction, it means that person who use this criteria always express sentiments, always express sentiments, and sentiment does not pay. And so we have to think like that. Maybe you may say he's not giving any solid answer. You are right. You are right, because there is no answer to achieve quality. There is no solid answer. It depends on. It relates to every step in construction. If you are say, which we start with soil, If your soil is not properly used, what structure then? If there is problem in soil itself, howsoever excellent structures it produce, that's prone to failure because of exclusive soil. Exclusive, I'm saying. It is exclusive, and for every exclusion, we have to understand this point. Soil is friend of none, but it can be friend of you, friend of structure. It can perform its way if we respect it and use it accordingly. If you think is no, this soil, this cow are same, let them down. Quality in construction is very, very complicated issue. Quantity is there. Quantity automatically comes in when you design something. Design means you have ensured all possible points to be covered when you think of contemplation. But design may be perfect, only time can tell that. Because quality is main point. And if there is no quality means your product, your project is useless. And quality starts from soil. I have seen many engineers talking of foundation failure, water in foundation affecting basement, like that. And there are so many problems because those people just assume something without experimentation. Okay, you cannot test it, at least you test yourself. If there's no laboratory in your area, you can't find a laboratory, you make your own laboratory, I mean to say assessment laboratory. At least you excavate somewhere and see how it behaves. Leave aside for a few couple of weeks and also see. You can check soil through water suppression system. I mean to say, you just take small quantity of soil, put in a glass of water, so all you can see. There's a layer after one or two. All see that this is this layer, this is heavier particles will come down, and middle particles keep suspending first and second layer, and other particles are more. Yes, more and more suspension means more and more danger. More and more suspension into a person who has no relation to someone else. That person is very small, I mean to say, not an old one. And that person can say, I know this and I don't know this. But when I meet someone and I score quality, that person will refer to me. This is theory, this is chapter, that is this test, that is this test, that is this test. This is testing method, that is. I know all that. Question is not that one. Question is conduct of soil. How much interest we take in that conduct. That's the important point. Let me see again. The same noting is coming. Same noting is coming. No reason of that. There's no problem. The signals are working, but you know, its lowest point is telling your connection is unstable. Please wait. We are reconnecting. I don't know. Continuous message comes here. Maybe due to some reason, I don't know reason for that. Well, it's already nearly 1:15. I'll just go out for 2 minutes again and come back. Hold on, I open my, sorry for disturbance. I have to open my lock, their door lock, because soil is very immense subject, very vast subject. It's related to geology, applied geology. It's related to vast volume of you know text. Soil is not simple. It's not formed in one day, and it's not necessary that whatever we see that is true. It keeps on changing. Soil near sea, soil near river, soil in desert. Soil depends on wherever it is. It cannot be understood easily. In engineering, there are many tests we conduct in soil. We have to find bearing strength of soil, its consolidation status, its compaction, or you can say shear strength. Or there are so many rock quality designations, means what sort of rock it is, how much can it settle, what is its grading. Grading means different types of particles in soil. There are varying types of particles. For example, clay particle size is very small, very very small. If I go in millimeter, I should say 0.0002 millimeter or even less, 0.002 millimeter. Means how much fraction of a millimeter? In 1 millimeter, we may say 2000 soil particles can be fixed in one line in 1 millimeter. Is that small? And you can say this compared to COVID particle, which is further lower than that. I'm just giving an example because COVID size is lesser than that clay particle. I'm giving an example. If you take other soil like sand, it's a much wider, much stronger, and it's not like clay. You may take lime, this is all completely different, and there are many, many more. All these work for your building. We include concrete in building or steel in building, or you can say brickwork, blockwork, or sheeting sometimes. Different ways of buildings, different types of building. Timber also we use before we used. We are using that material which is quite same, which is quite strong. We are sure that this is strong, but that same material, this product, this building is going to stay on something we are not sure of. Yes, we are not sure of. There's a reason for that, because it's not clearly understood. In same area of a building, in same area, there may be different types of soil stratifications. Say my building is a, let's say, 100 meter by 50 meter area is there. I construct a building in that. In that meter, 100 meter by 50 meter, there may be many types of soils. But I have to find best solution for that, and that can be obtained only by soil investigation. That's why we call it soil investigation, because we have to investigate every aspect of that layer where we want to hold soil, or we want to find depth of our foundation where we should hold it. Sometimes even up to 3 meters we don't find good ground, and sometimes it's even a half a meter we find good ground. But we have to see best one. In civil engineering, you know, best one is required, and best one is not understood. What is best one? So then we apply some factors. Simple. Apply some factor. Factor is this, means whatever test says, whatever test declares that this is I am having this value. Many tests declare that on an average I am this value. We never use that value in our designs. Depending on circumstances, depending on nature of soil, and depending on our experience, we apply some factor, sometimes three, sometimes four, even sometimes in rare cases, five also. Suppose I find that this soil is having 50 tons per square meter capacity. 50 tons is 50,000 kilogram. And when I say per square meter, means 1 meter by 1 meter of soil can take that much stress, that much load. So I say, okay, soil is happy to take that load. I'm not happy to give this load to soil, because I am interested in welfare of soil also. I have to shield soil black future. I don't want to kill my soil by my structure. I would say, okay, I accept this 50 tons, but I divide it by 3. I want to stress the soil just 33% or one third. I cannot then allow more load on that soil. And then I can assure, because there is safety margin, then I feel confident to some degree that this building will not fail in foundation, or this soil shall not cause failure to this building. One and same thing. This is what we usually do. If you say no, I will take full load. It's my right. I can't. Soil can't stop me from doing that. Soil shall never stop you, because soil cannot stop you. And if I say 50 tons per square meter is accepted, I will give 50 tons to this. Then this is not engineering, because you have decided only local value. You have not considered other values. When we do test in varying soils, we do not test only at one place, we test in different locations. Or we may drill holes and we check various levels, how much on site that is giving, and after working into samples, what laboratory test says. Maybe there are 10 results in one area of building. Which one is best? and how it can be assumed that it will stay in future. What is surrounding area? What is source of water that can seep into foundations? Means all these considerations, and what is electrical current that can pass through this? How much is that? We call it electrical resistivity and also electrical connectivity. Conductivity, you mean second as a connective conductivity. If both are known, conductivity and resistance, resistance of soil to electric current, and also we have to see status of thermodynamics or heat application on soil. How will it affect soil? These are prime considerations. Other than how much load it can take, how many, that is different. I'm talking of something very much logical that is related to strength of soil. Because soil is father of building, soil is, you can say, support of building, and if this fails, building fails, structure fails. Therefore, soil must be understood very well, thoroughly. People don't conduct tests, I know. They are so expert that by weaving they will say it's okay, very good soil. They do not know ABCD of soil engineering, and they can say, oh, it's excellent, very good. There's a problem there. We have to resolve. And that problem can be resolved only by factor of safety. We call it, this is factor of safety, and that test which we conduct, that is, and failure of soil at that test, that is called ultimate bearing capacity. Ultimate bearing capacity cannot be used in designs. We have to extract out working bearing capacity by application of factor. And this is not only in designs of soil, this also applies to designs of yielding material, non-yielding material. It is very important. So we must not sleep throughout designs. We must not sleep for quality requirements. If we cannot do this, then we should not boast that we are so powerful people in construction. If these people, these patients have been turned back because of some, yes, your laboratory is not strong enough, is not resistance, and we are leaving. What it says. So what I always say, we have to be considerate on this issue. Quality is not just, vertical line or horizontal line. It's not just finishing of surface. It's not painting on that. Or if you see beautiful building, what attraction, what's beautiful elevation, that is not quality. That is attraction. Attraction only. That is makeup. Makeup. Ladies makeup, gents makeup these days. All makeup for what? Just to have attraction. Your body may be strong or not strong. You may have strength or no strength. You may sit in sun or no, don't sit in sun for long. But your body should be well dressed. It should be attractive. And you call it, I have something. Status, what's something? Your building may not be strong. Your structure may not be strong. And you are happy with finishing items. Then I don't understand meaning of quality. In that case, you want to live in danger zone with good finishes. If you consider that, okay, fine. People usually don't value structure, usually. This is my experience. They don't care for structure because it's not because they don't like, but they are ignorant. They fight for finishes, they fight for glazing, they fight for attraction, they fight for light, they fight for green building effect. Okay, that's fine. I'm not going to say no to that. That is your right, your money. But don't forget, there is another right also on structure, but you don't realize that one. If I can't stand, I can't walk due to whatever reason. See, my clothes are very beautiful. See, I shave every day. See my beauty, my attraction on this. Do you like that? Or do you like to be strong mentally as well as physically? Can you see quality is not limited to definition. Quality is not limited to certain defined criteria only. Whoever does it, whoever works on this on site, that person must be strong. If there's a problem, that person must have capacity to review that through some records and then say, yes, this is what I wanted, this is what I have. So when I talk of this, I know many people don't like it, least bother about that. It's not up to liking of people. What is destiny? What is objective? And that is safety for everyone. Safety for everyone, whoever would be occupant of that building, that structure in future. We are interested in that. As an engineer, as a person, I'm not interested in wasting time for those people who do not have analytical power and they depend on self. And you can say, now I will not take much time because I lost my time today. I lost a lot of time today morning. Actually, I wanted to talk for more than 3 hours. But three attempts, I tried four attempts on Facebook and I lost time. Then I thought something I should give on YouTube because, but it is unfortunate that YouTube has limited relay. It doesn't relay our documents. If we, there's no such provision. But interaction, okay, I thought I would do with you. I in past also usually do that. I have seen that even then there are no so many people who are interested in such types of talks. They are not interested in such talks, and but I think these talks are very very important. Important because self impression by self going to college university is important for young, but it's not important for all those who do that. I will continue quality. I'm not going to stop on that because of this reason or that reason. Because quality is life. I would again say it's not in construction alone, it's life question. It's life. My quality is life. Everybody has quality criteria, even students, professionals, those who work. There's a quality everywhere, and if there is no quality, there's expectation of quality. Of course, you will not find same level of quality they should have, but they have to improve. Nothing wrong with that. You can improve. I am talking of quality. It doesn't mean I'm everyone. It doesn't mean I know everything, but whatever I know, whatever I could tell you, I tried that. Sometimes quality and quantity dispute together because contractors least bother about quality as far as they are paid. I have seen here in my area in Faridabad, a project is going on, that is infrastructure project for rainwater collection and treatment. Very big one, means all over here. And not, I can speak name of contractors also. That's L&T. They consider themselves world-class contractors. But what they are doing here, I'm ashamed of. Very frankly speaking, I'm ashamed of. No plan, no program, no quality, nothing. They are just doing do anything. What is that? People say should not take name. I say I should take name because quality requires that. They befool people, they befool engineers, and engineers are befooled. Planless project, programless project, qualityless project, and they have been working, and it's I think happening all over our nation. That's not good. Sometimes work is so easy, and we think it's so easy, and we can do any time. And sometimes it's so difficult, and we think no, we'll take time. But it depends on your conception, it depends on your intelligence, it depends on so many factors, and it depends on past experience also. Sometimes you find I did this before, so there's no problem in that. But when you go on to read its soil investigation report by some test laboratory, you will find complete different picture. All know about this, civil engineers know about this, architects know about this happens, but nobody cares. It's very important point you have to note. Quality is dependent on your inclusion into that project. If you don't include your power, you say, oh no, leave it aside. We'll see so many buildings have been carried out, nothing happened to them. When you know something, it happens. Sometimes what I should say, थोड़ा हिंदी में बोल रहे हैं. نہیں لوگ پسند کریں گے نہیں کریں گے، کہہ نہیں سکتا، پسند آئے نہ آئے لوگوں کو، کیونکہ پروفیشنل ٹاک ہے، لیکن تھوڑا بولنے کا تو انسان کچھ نہیں ہے۔ گنوتا بہت ضروری ہے زندگی میں، ہم جانتے ہیں، اور اگر آپ کو اسٹرکچر بنانا ہے، مکان بنانا ہے، بھون بنانا ہے، کچھ بھی بنانا ہے انجینئرنگ میں، سڑک بنانی ہے اور واٹر لائن ڈالنی ہے، سیور لائن ڈالنی ہے، شیڈ بنانا ہے، کچھ اور بنانا ہے، کوالٹی اگر نہ ہو تو آپ کو کیسا لگے گا؟ آپ کچھ سوچ لیجئے۔ آپ کو کھانا کھانا ہے، رسوئی بنانی ہے، آپ کے کھانے میں نمک زیادہ ہے یا کم ہے، کوالٹی نہیں ہے کھانے کا، آپ کیسا لگے گا؟ آپ سوچ لیجئے۔ سڑک اچھی نہیں بنی، آپ چل نہیں پا رہے، چلا نہیں پا رہے گاڑی، آپ کا فٹ اچھا نہیں، کیسا لگے گا؟ آپ سوچ لیجیے۔ کہنے کا مطلب ہے جب تک بالکل صاف ستھرا آپ کو نہ ملے کام اچھا سے ڈھنگ سے، آپ کو لگتا ہے میں کہاں پھنس گیا، کیا کچھ پرابلم یہاں پہ اتنے سارے تار جا رہے ہیں بجلی کا، سمجھ نہیں آتا کون سے بات کہاں کنیکٹر ڈسٹریبیوشن بورڈ میں، وہ سب چیزیں ایبسنس ہے۔ آپ نے اپنے آپ پڑھائی کی، آپ بعد میں کسی اور نے کری، آپ کی جگہ، وہ ایک ایبسنٹزم ہے۔ کوالٹی صحیح لانا اگر اتنا آسان ہوتا تو بات ہی کیا تھی۔ ویسے اتنا مشکل بھی نہیں ہے، آسان ہی ہے، لیکن وہ آسان تب ہوتا ہے جب کوئی کرنا چاہے۔ ہمیں اچھا کرنے میں کیا کرنے چاہیے؟ چلتے ہیں کبھی کبھی کچھ کرنے کے لیے، لیکن کر نہیں پاتے، ایسا ہوتا ہے۔ سوچتے ہیں، سپنا لیتے ہیں، لیکن کر نہیں پاتے۔ ایسی استھتی نہیں ہونی چاہیے۔ اگر آپ پیسہ لگا رہے ہیں، کچھ سوچ رہے ہیں، آپ کو لڑنا تو پڑے گا حالات سے، کیونکہ کوالٹی بھی لینا ہے ایسے دیش میں جہاں کوئی کوالٹی چاہتا نہیں، آسان نہیں ہے۔ کسی آپ ورکر سے بات کر لیجئے، کسی میسن سے بات کر لیجئے، کسی کارپینٹر سے بات کر لیجئے، کسی سے بات کر لیجئے، ویسی باتیں کریں گے، ان سے بڑے کوئی کوالٹی دے نہیں سکتا۔ کسی سے آپ بات کر لیجیے، یہ ہمارے دیش کا فیشن ہے، ارے گارنٹی ہے ہماری، وہ گارنٹی کہاں سے دے گا وہ بھی نہیں جانتا، لیکن گارنٹی دے دیتا ہے۔ یہی تو بیوٹی ہے، اس کے جیسا کوئی کام ہی نہیں ہوا آج تک۔ ہر آدمی ایسا بولتا ہے ہم نے ایسا کام کیا کوئی کر نہیں سکتا۔ میں اسے کوالٹی نہیں مانتا، میں اسے بیوقوفی مانتا ہوں۔ آپ نے اتنے کام کیے ہوں گے، بہت سارے کام کیے، آپ نے 50 بار کیے، اس کا مطلب آپ کو کوالٹی نہیں آتی، تو آپ نے غلط کیے وہ سب۔ اگر آپ کوالٹی نہیں سمجھ پا رہے ہیں، نہ سمجھا پا رہے ہیں، نہ آپ جان رہے ہیں، اور آپ نے ویسا ہی کیا ہوا، مان لیتے ہیں تو بھائی آپ نے مان لیا، ٹھیک ہے۔ جتنا لڑو گے سرکمسٹانسز سے، اتنا ہی اچھا کام کر پاؤ گے، لیکن لڑنا تو پڑے گا، ہر چیز کے لیے لڑنا پڑے گا۔ یہاں کوئی نہیں سنتا، کوئی نہیں سنتا ہے۔ انجینئر نہیں سنتے کیونکہ وہ آرکیٹیکٹ ہی مان لیتے ہیں، ان کو فورس کر دیتا ہے۔ بہت سی باتیں ورکر نہیں سنتے، چارج ہینڈ نہیں سنتے، اس لیے آپ کو اپنا جاب رسپانسبلٹی ڈیسائیڈ کرنا پڑے گا. ابھی بھی دیکھو سوچتے ہیں لوگ نیوز سے ارے اتنا تو ہمارے پاس ہے، ہم اتنا پیدا کر لیں گے. خواہاں کی باتیں، خواہاں کی باتیں. آپ کیسے پیدا کر لیں گے بھائی؟ کیا کر لیں گے آپ؟ مطلب ٹاک، ہم ٹاک کو کوالٹی مانتے ہیں. ٹاک، بات چیت، بڑی بڑی صلاح، بڑے بڑے ڈائریکشن، بڑے بڑے مشورے، لیکن اس کا پرنام سب جانتے ہیں. سب جانتے ہیں. کچھ کہنے کی ضرورت نہیں ہے. کہنے سے کچھ ہونا بھی نہیں ہے. اسی لیے اگر آپ کوالٹی کو سمجھتے ہیں تو ٹھیک ہے، اور نہیں سمجھتے تو بھی کوئی کیا کر سکتا ہے. پیسہ آپ نے لگانا ہے، آپ کے گھروں سے لگانا ہے. Now we have to think of for future, and it should be, it should not be dramatic actually, it should be real one. کوالٹی تو آنے میں ٹائم لگے گا پبلک میں، کیونکہ پہلے ابھینتاؤں کو، انجینئر کو اسے سمجھنا ہوگا. میں یہ نہیں کہتا کہ وہ نہیں جانتے ہیں، لیکن لاپرواہی تو ہوتی ہی ہے. لاپرواہی ہوتی ہے اور ڈیڈیکیشن ڈیووشن نہیں ہوتی ہے. ایسا بھی ہو سکتا ہے. میں یہ نہیں کہہ رہا کہ انٹرسٹ نہیں لیتے لوگ، لیکن انٹرسٹ نہیں لینے کے لیے ایسا واتاورن تو تیار کیا جا سکتا ہے کہ وہ انٹرسٹ نہ لیں. آفا دافی جلدی کرو جلدی کرو، پش کرو، یہ کرو وہ تو ہوتا ہوگا. اور ڈیزائن کو نہیں سمجھنے نہیں دینا، کوآرڈینیشن نہیں کرنے دینا، جلدی جلدی جس کر دو، کیسے بھی کر دو، دیکھا جائے گا. کوآرڈینیشن بہت ضروری ہوتا ہے. میں نے بات نہیں کی کوآرڈینیشن کی بات نہیں، لیکن کوآرڈینیشن کے بنا کوالٹی نہیں آ سکتی. ہم سب کو یہ سمجھنا چاہیے. جو لوگ اس بات کو نہیں سمجھتے وہ شاید سمجھیں گے بھی نہیں، وہ سمجھنا چاہتے بھی نہیں، اور یہ بھی ایک سمسیا ہے. اپنے آپ ہو جائے گا، سسٹم چل رہا ہے. یہ سب کہنے سے کنسٹرکشن میں نہیں چلتا. کنسٹرکشن کے ہر سینئر آدمی کو، ہر انجینئر کو بھاگنا دوڑنا پڑتا ہے. اور نہیں تو کام کراؤ گے، خود نہیں بھاگو گے، پتہ نہیں لگے گا، غلط کام بھی صحیح دکھے گا. کنٹرول کے بنا، صحیح کنٹرول کے بنا کوالٹی نہیں آ سکتی. بار بار سمجھنے سے تھوڑا آتا ہے. ناؤ ابھی میں سوچ رہا ہوں ایک آدھ منٹ میں اس ویڈیو کو ڈاؤن کروں. کوالٹی وہ کوالٹی ہے، کلا ہے صحیح کام کرنے کی. وہ کلا کیسی ہو، یہ تو فیصلہ کام کرنے والے کو کرنا ہوتا ہے یا کام کرانے والے کو کرنا ہوتا ہے. وہ کتنی لمٹ تک جائے، کتنا پیچھے رہ جائے، کتنا آگے جائے، کتنا خود سنتشٹ ہو، اور کتنا صحیح ہو، یہ تو ڈیسائیڈ کرنے والا وہ خود ہے. اس کا اپنا ڈیزائن ہے. اگر وہ نہیں کرے گا تو کوئی بھی نہیں کرے گا. آپ نے خود فیصلہ کرنا ہے ہمیں کتنا کام صحیح کرانا ہے، کتنا صحیح نہیں کرانا ہے. اور آپ نے خود ہی فیصلہ کرنا ہے کہ کتنا کام صحیح ہو گیا. سیلف سیٹسفیکشن بہت ضروری ہے کسٹمر سیٹسفیکشن کے لیے. اگر آپ خود ہی سنتشٹ نہیں ہیں تو گراہک کو، کسٹمر کو کیا سنتشٹ کریں گے؟ یہ پرشن اپنے آپ میں اٹھتا ہے. اور کیا کریں، ایسے ہی چل رہا ہے، دھکا مار، غلط سلط سب چل رہا ہے. وہ کہتے ہیں آج کل کیا ہے، نام بڑے ہیں درجن چھوٹے ہیں. صحیح بات ہے، بڑی بڑی کمپنیاں ہیں، بڑے بڑے بورڈ ہیں، بڑی بڑی سیفٹی ڈریسز ہیں، بڑی بڑی گاڑیاں ہیں، سب کچھ ہے. لیکن گنوتا نہیں ہے کام میں، وہ بھی سچ ہے. گنوتا لانا آسان نہیں ہوتا، کیونکہ اس کے لیے گن والے آدمی چاہیے، گن والے انجینئر چاہیے، گن والے ورکر چاہیے. اور سمے ٹوٹ بھی جائیں گے اور دوسرے کام کریں گے. یہ سب باتیں دھیان میں رکھنے ہوتی ہیں. کوالٹی بچوں کو کھیلنے کی ہم نے ایسا کیا اور کوالٹی آ گئی، یہ کنسٹرکشن کی کوالٹی ہے. یہ کوالٹی آسانی سے آتی نہیں ہے. آج تو یہ ہے کہ بہت سے لوگوں کو کوالٹی کا مطلب ہی نہیں پتا. ہم کو یہ باتیں خالی بولنے کے لیے نہیں کہہ رہے، یہ کرنا بھی ہوگی، یہ کرنا بھی ہوگا. اگر ہم کوالٹی چاہتے ہیں، ہم کو سمجھنا بھی ہوگا اور سمجھانا بھی ہوگا، لکھنا بھی ہوگا، لکھانا بھی ہوگا، بولنا بھی ہوگا، بلوانا بھی ہوگا، اور سب سے زیادہ سائٹ پہ دھیان دینا ہوگا، ڈیزائن پہ دھیان دینا ہوگا۔ اگر ڈیزائن اچھا ہے اور سائٹ پہ اس کو کرنے والا اچھا نہیں ہے تو کوالٹی کبھی نہیں آئے گی، اور ڈیزائن اچھا نہیں ہے، سائٹ پہ کرنے والے اچھے ہیں، پھر بھی کچھ ہو جائے گا۔ لیکن اگر دونوں اچھے ہیں، وہ چاہیے ہم کو، دونوں سمجھتے ہیں، ایک دوسرے کے راستے پہ چلتے ہیں، تو ایسے حالات صحیح ہوتے ہیں۔ وہی ہونے چاہیے کمپلائنس، کریانوین، جو کہ ہمارا کلچر میں نہیں ہے، سنسکرتی نہیں ہے ہماری ایسی۔ ہم سمجھنا نہیں چاہتے، سمجھانا نہیں چاہتے، کرنا نہیں چاہتے، کرنے دینا نہیں چاہتے، یہ کوالٹی میں نہیں چلے گا۔ ایک بار جو سمجھ لیا، جو کر لیا کہ ہمیں ایسا ہی کرنا ہے تو ویسا ہی کرنا ہے، اگنور نہیں کر سکتے آپ، بھاگ نہیں سکتے آپ، یہ نہیں کہہ سکتے اس بار تو ہو گیا اگلی بار دیکھیں گے، یہ نہیں چلے گا۔ کوالٹی میں ایسا نہیں ہوتا کہ اس پروڈکٹ کو تو میں نے غلط کر دیا، آگے سے دیکھیں گے، اس کو مان لیجیے آپ، ایسا نہیں ہوتا، ایسا کبھی نہیں ہوتا سول میں۔ اگر ایسا ہوتا تو پھر انجینئرنگ کا کوئی مطلب نہیں رہتا، کوئی مطلب نہیں رہتا۔ ہم کو یہ سب سمجھنا ہوگا، اور اگر ہم یہ نہیں سمجھتے بھائی ہم کچھ نہیں سمجھتے، ہم کوالٹی نہیں سمجھتے، ہم کوانٹٹی بھی نہیں سمجھتے، ہم انجینئرنگ نہیں سمجھتے، اور صحیح معنوں میں ہم کہہ سکتے ہیں کہ ہم اشکشت ہیں، ہم ابھینتا نہیں ہیں۔ ان سرٹیفکیٹ کو جو میں دکھاتا ہوں آپ کو کوئی مطلب نہیں ہے، میری پڑھائی خالی ایک کاغذ کا ٹکڑا لینے کے لیے ہوئی، اس سے زیادہ کچھ نہیں۔ اس کاغذ کے ٹکڑے کا میں کیا کروں؟ جب وہ بلڈنگ جو بناتا ہوں، جو میں بھون بناتا ہوں، جو پروجیکٹ بناتا ہوں، وہ نہیں کہہ رہا کہ یہ کاغذ کا ٹکڑا آپ کا ٹھیک ہے، تو میرے وہ کس کام کا؟ اس لیے اگر آپ کو اپنے سرٹیفکیٹ کی سچائی بتانی ہے تو آپ کو کام کرنا پڑے گا، نہیں تو باتوں سے کام نہیں چلتا، بات کرنے سے کام نہیں ہوتا، خالی لیکچر دینے سے بھی کام نہیں ہوتا، کام تو کرنا پڑتا ہے۔ یہ بات کو ہم جتنا اچھی طرح سمجھ لیں گے، اس کے لیے آپ کو دृڑھ سنکلپ ہونا ہے، ڈٹرمنیشن میں ہونا ہے، کمٹ ہونا ہے۔ اپنے آپ کچھ نہیں ہوتا، یہ لوگ کہتے ہیں جلدی سے اپنے آپ ہو گیا، قدرت نے بنا دیا۔ ارے قدرت نے تو ہم کو بھی بنایا ہے، آپ کو بھی بنایا ہے، اور آپ کو ہم کو اس لیے بنایا ہے کہ آگے والی چیز وہ چاہتا ہے آپ اس میں کنٹریبیوٹ کریں، یہی پرپس ہوتا ہے۔ میں زیادہ اب لمبا چوڑا نہ بولتے ہوئے، آگے کا دھیان رکھتے ہوئے کہ آگے مجھے کیا کرنا ہے۔ آج تو میں نے ہوا بازی میں بولا کیونکہ میں ڈاکومنٹ نہیں دکھا سکتا تھا آپ کو، ہوا بازی ہے، ہوا بازی ہی صحیح، کچھ تو ہے۔ کوالٹی میں ہوا بازی کیا چلے گی، لیکن جب مجبوری ہوتی ہے، کام نہیں ہوتا، ہمارا ویب سائٹ کام نہیں کر رہا، ڈاکومنٹ نہیں دکھا پا رہے، تو اتنا ہی صحیح، جو ہو جائے وہی صحیح، کم سے کم کچھ سوچ تو لیا، کچھ بات تو ہو گئی، اتنا ہی کافی ہوتا ہے کئی بار۔ لیکن ہم کوالٹی سے گریں گے نہیں، نہ گریں گے، اور لڑیں گے، ان سے بھی لڑیں گے جو ہم کو پیمنٹ دیتے ہیں، ان کو بھی لڑیں گے جن کو ہم پیمنٹ دیتے ہیں۔ کوالٹی ایک اپنے سے یدھ ہے، ایک دوسروں سے یدھ ہے، گولی باری کا یدھ نہیں ہے، سچائی کا یدھ ہے، کام کروانے کا یدھ ہے۔ اس کو ہم کو پکڑنا ہی پڑے گا، نہیں تو ہم گر جائیں گے۔ یہ بات ہمیں اچھی طرح سے سمجھ لینی چاہیے۔ دھنیہ واد۔